welcome to Raos Academy. In before session we have discussed erosional landforms of fluvial. Under fluvial landforms we have seen erosional landforms. Today we are going to learn depositional landforms and karst landforms and glacial landforms. So let's start the session. First, depositional. Depositional landform, it's aggradational process when velocity of river decreases, gradient decreases and load increases. When these three happens, you will see depositional. Now a river carrying load from here and it is traveling, it is flowing from here, from young stage. When it reaches old stage or mature stage, here old stage, what happens? After reaching here, the gradient decreases, the slope also decreases, velocity of the river decreases. When the speed in a direction decreases and load is increasing, so what river will do? It will deposit. Now continuous deposition of this load creates depositional landforms, means it is aggradational. Erosional, degradational, depositional, aggradational process. Now different types of depositional landforms we are going to learn. First, alluvial fans, fan shaped deposits, coarse material near apex or finer outward. When river carrying fine materials from mountains, river flowing formed at foothills. Now river is flowing like this. Here at foothills, fan shaped deposits of alluvium. Those fan shaped deposits are known as alluvial fans. Sudden decrease in river velocity. Why this deposition happens? Because of sudden decrease in river velocity. River emerges from mountains to plains. It is coming from mountains, it flows very fast. When it reaches plains, the velocity decreases, loss of carrying capacity. Because of the velocity it decreases, loss of carrying capacity here. From mountains, here feeder channel, when a river deposits in a fan shaped or cone shaped at foothills, that alluvium deposits are known as alluvial fans. Next, floodplains, flat, fertile, low-lying areas composed of fine alluvium. Overbank flooding, because of overbank flooding you will see floodplains at the banks of the river composed of fine alluvium, very fertile soil you will see in floodplains. Repeated deposition during flood, because of floods, in floods you will see repeated deposition. Because of that repeated deposition, fine alluvium is get deposited there, and because of that fine alluvium you will see flood plains are formed. Those are very fertile. Gangetic flood plains in Uttar Pradesh we are going to see. Now natural levees, raised river banks. Natural levees are formed at meanders. Now meander is a loop shaped river flowing in a loop structure or a S-shaped sinus way. Why this? Actually meander is not a landform, it is a pattern of flow of river, because whenever you take any water body have a propensity. Propensity means a natural way or a natural pattern, natural tendency. Propensity of water means natural tendency, natural tendency to behave in a certain way. Because of that, an unconsolidated alluvium material. Because of this unconsolidated, they are not sorted. Because of this unconsolidated, now the river flows in a curved structure. After that, one more thing, Coriolis force. What Coriolis force will do? Rotating force. It will deflect, same like wind, it will deflect water also. So these three are very important reason they can ask in statement based questions. First, propensity of water, unconsolidated alluvium deposits. Next, Coriolis force, deflection you will see. Now when river is flowing, what you will see? Now it is continuously flowing. Here inside concave side you will see deposition. Here you will see cut off, erosion. On convex side, erosion is happening this side, deposition is happening this side. Now when deposition happens in a linear way inside concave side, those are known as point bars. Point bars. Here on convex side, low parallel linear ridges. When low parallel linear ridges formed because deposited, those are known as natural levees. Natural levees. Clear? Here, raised river banks, coarse deposits near channel, find sudden fall in velocity. Because of sudden fall in velocity, here you can see these are the natural levees. Inside convex side you will see point bars, large linear deposits, those are known as point bars. Concave side, here convex side natural levees, concave side, concave, this is a concave mirror, right? Convex like this. Now this side you will see natural levees, this side you will see point bars. Here when river is flowing like this, it is depositing at inflection point. Inflection point means the point where a river channel is reversed, the direction is reversed, direction of the channel curvature reverses. Now it is going like this, it curvature, you will see curvature reverse, that point is known as inflection point. After continuous erosion at inflection point, you will see break off, cut off this inflection point, and here we will see a oxbow lake. Means this oxbow lake is separated from mean deer, because here you will see at inflection point you will see erosion. Now it is going like this, like this, like this. Here at inflection point you will see continuous cut off. Now this cut off lake is known as oxbow lake. Now oxbow lakes, horseshoe shaped water bodies, cut-off meanders. They are known as cut-off meanders. Next, braided channels. See, first we will talk about deltas. Same like alluvium fans only, these are the deposits of alluvium, but at some other place near sea. Near sea you will see these deposits. Wherever you see calm sea, if tides are not strong, at that area you will see these deposits near sea here. Now river is taking, here you will see delta formation. Delta developed at different location, alluvial fan developed at different location. The load is not carried into the sea, they are distributed along the coast. They are distributed along the coast. You know Godavari delta, they are very fertile, triangular or fan shaped deposit, distributary channels. When the river is flowing, here you have seen depositions, and this river flows in it splits in delta, and those splitted water channels are known as distributaries. Tributaries means one more river is coming and joining one other water channel. For example, Musi is there, Musi river, here Krishna. Musi river is coming and joining Krishna, means Musi is tributary of Krishna. But when this Krishna river splits into more water channels, those are known as distributaries. Tributary, another channel, one more river water is coming and joining. Distributaries, river is splitting into channels. Okay. Next, landforms related to groundwater or karst topography. Here, karst topography refers to landforms created by the chemical action of groundwater on soluble rocks. Chemical action on soluble rocks. Here you will see carbonation. Carbonation process we have learned earlier. That carbonation process you will see here. Key process carbonation, most common in limestone and also in dolomite and gypsum. This you have to remember, most of the students they remember karst topography means only limestone. No, not only limestone, in dolomite and gypsum regions also we will find these landforms. Here what happens, when rainwater mixes with CO2, it produces carbonic acid. This carbonic acid reacts with limestone CaCO3 and produces CaHCO3 bicarbonate. This is dissolvable in, it dissolves limestone. This carbonic acid dissolves limestone. When limestone is dissolved in the rock, you will see different types of landform formation. Here, conditions very important. First condition, soluble rocks like limestone is very important for karst topography. High rainfall because continuous permeability of rainwater has to be there. Jointed and permeable rocks, you have to there we should have joints or cracks or permeable rocks. Thick vegetation, why thick vegetation? Because of we need more CO2. Long geological time means continuously process should happen. Next, first in erosional, same in groundwater landforms also we are having erosional and depositional landforms. Erosional landforms, sinkholes or dolines, small to medium sized funnel shaped depressions formed by solution or collapse of the surface layer. What happens here? Surface. Now rocks are soluble. Here you will see small depression because of that because of soluble nature. Now limestone is soluble in groundwater. Here you will see erosion. Because of this erosion you will see depression here. Now swallow holes or ponars, a hole or opening through which surface water drains into underground. Now this drainage, underground drainage is also very important. Next, uvalas, a large complex depression formed by coalescing of multiple sinkholes. Here you can see first erosional features, pinnacle or cliff or lapis, we will call them as lapis. After continuous erosion we see swallow hole, and then after continuous erosion you will see cast window. After continuous erosion of dolines you will see uvalas. After continuous erosion you will see polge. Polge or blind valley, a large flat flowed depression with steep sides often formed by collapse or erosion. Collapse of uvalas or collapse of that depression you will see the formation of polge. These names you have to remember. Mostly they do not ask about formation, but conditions they can ask and they can confuse. These are erosional or depositional. They can give this polge in glacier landforms, and which among are these are related to ground water landforms, or they can ask about glacier landforms. Next, caves, subsurface voids formed as a groundwater dissolves rocks along the joints. Underground you will see the cave formation. Lapis, limestone pavements heavily grooved. Here if you see the picture easily you can remember. Here cracks you will see, these are the limestone like pavement you will see, those are known as lapis. Erosional, what you have to remember? Sinkholes or dolines. Next, ponar. Next, uvalas, polge, caves, and lapis or limestone pavement. Sinkholes, ponar, uvalas, polge, lapis and caves, erosional. Next, depositional. Depositional or ice like calcium carbonate deposits that hang from the ceiling or a cave, formed by water dripping or evaporation. Here Underground you will see depositional features. These are stalactite, stalagmite, stalactite, stalagmite. Stalactite. Here you remember C is related to ceiling, like that you remember. G is related to ground or lug, or you can remember as leg, and down to the surface. Most of the aspirants they get confused here. Stalactites, calcium carbonate deposits that hang from the ceiling. They hang from the ceiling, formed by water dripping and evaporation. Next, stalagmites, upward growing. Now water is dripping, upward growing from surface. Those are known as stalagmites. Now pillars, vertical columns formed when these stalagmite and stalactite meet. When these two meet, they form a pillar. They form a pillar. They fuse and they form a pillar. So, before going into glaciers, first we will see fast revision. Erosional, and first we will see erosional. Erosional landforms. What are erosional landforms? We have seen V-shaped valleys, gorge, canyon, all this comes under valleys. Next, after canyon, what we have seen? Plunge pool, potholes, rapids, cascade and waterfall. Next, depositional. Under depositional, alluvial fans, natural levees, point bars, floodplains, next deltas, now when you talk about mean deers, they are both erosional and depositional. Here you will see both erosional and depositional. On that flow pattern you will see erosional landforms. Because of the erosion of inflection point you have seen oxbow lake, and oxbow lake is formed because of the deposition. Now depositional landforms we have seen point bars. Point bars, natural levees, all those on mean deers. Next, one more thing we have missed, river terraces. When a a floodplain erodes vertically. When a floodplain erodes vertically, its own deposition. Here floodplain is there. Now this stream coming, and this stream erodes its own floodplain, vertical erosion, and because of this vertical erosion you will see step like terraces. Vertical erosion of its own deposition. Now stream erodes its own deposition vertically, then you will see terrace formation. When on both the sides of the stream they are formed parallelly with equal height, those are known as paired terraces. When they are not parallel, they are not symmetrical, they are known as unpaired terraces. Here in river terraces, first deposition. After deposition, what we have seen? Own floodplain erosion. What erosion? Vertical erosion. Vertical erosion of its own deposition. Stream erodes its own deposition in vertically. Next, karst landforms. First main thing, carbonation, limestone, dolomite, gypsum. These you have to remember. Soluble rocks, rainfall. These stalagmites and stalactites, Meghalaya region, where you will see heavy rainfall, and even Andhra also, in some movies we have seen these caves. Next, karst landforms, erosional, lapis, sinkholes or dolines. After dolines we have seen ponar. Next, ovalas, polje and caves. Here depositional, stalactite, stalagmite and pillars. Stalagmite, C, ceiling, hanging from the ceiling, G, ground. These you have to remember in karst landforms. They can ask like this, conditions regarding karst topography. For karst topography, condition requires in one statement they can ask dry conditions, or some other mineral they can ask, or some other only limestone they can ask. Like that they can ask in karst landforms. First we will solve some MCQs. Now, it is consider the following statements about exfoliation. We have learned about exfoliation. It is more common in humid regions. It is caused due to differential expansion and contraction of rocks. It is an important process in the formation of Inselberg. Inselberg we are going to discuss. Actually 2 and 3 is the answer. It is more not, it is common in dry areas, dry regions, because of differential expansion and erosions. Outer layers expand. See, exfoliation occurs mainly in arid regions due to temperature variations. It contributes to Inselberg formation. Inselberg formation we are going to learn in wind landforms. Next, which of the following processes is primarily responsible for the formation of karst topography? Which process, which weathering or deposition they are asking? Mechanical weathering? We have seen any mechanical physical breakdown? No. It is due to chemical weathering. Chemical weathering, carbonation. In chemical weathering, because of carbonation process, not deposition, not volcanism. Next, which of the following correctly represents the sequence of river landforms from upper to lower course? A. Mean deer to waterfall to delta, George, mean deer, delta, delta, mean deer, George. Floodplain, George, delta. First, valley. Delta is formed at the mouth, right, near sea. So, delta has to come at the last. So, you can eliminate this. You can eliminate C. Next, first mean deer at young age, very steep slopes, water flows vertically and you will see vertical erosion. At vertical erosion, what forms? Valley formation. Different types of valleys we have seen. George is a valley. First, George. Next, mean deer at mature stage. Next, delta at lower course. Upper course, valley. Middle course, mean deer. And then at lower course, you will see delta. Now, consider the following statements regarding weathering. It is a static process. It leads to formation of soil. It requires slope gradient for operation. About weathering they are asking. Yes, it is a static process, means it is in situ, it is in situ process. You do not see any transportation. So, one is correct. It leads to formation of soil, yes, it leads to formation. After weathering, you will see other processes. Because of that breakdown, rock fragments, bedrock is, after weathering of bedrock only, you will see formation of soil. It requires slope gradient for operation? No. It is in situ process. There is no need of any slope gradient for operation. So, 1 and 2 is the correct answer. Now, which condition is most suitable for the formation of deltas they are asking? First, A. Strong tidal action. B. Steep river gradient. C. Large sediment supply and calm sea. D. Continental shelf. If strong tidal action is there, can delta or a river course can it deposit? Steep river gradient is there, steep river gradient. Large sediment supply has to be there and calm sea with low tidal action. Large sediment supply with calm sea has to be there for delta formation. Next, stalactites and stalagmites are formed due to first, mechanical deposition, evaporation of groundwater, chemical precipitation of calcium carbonate or fluvial deposition. Calcium carbonate is harder, right? Now, when the calcium carbonate chemically precipitates, through dripping, you will see formation of stalagmites and stalactites, chemical precipitation of calcium carbonate. Calcium carbonate you have to remember in karst topography, not fluvial deposition. Ice movement. Now, glacier landforms we are going to see. First important thing, what is a glacier? Glacier means a huge ice? No. Static ice is not a glacier. When ice, a huge body of ice moves, you will see movement, then it is known as glacier. Glacier is a huge mass of ice that moves slowly over land. Movement has to be there. Then only we will call that ice as that large mass of ice body as a glacier. The term glacier comes from the French word glacier, means ice. Glacier are often called rivers of ice. Glacial landforms can be found in location that currently they do not have any active glaciers also. Means before now we have, if that location is in post glaciation period, you do not find any glacier there, but we find glacial landforms there. Essential condition for glacier formation, first, continuous accumulation of snow. Continuous accumulation of snow and low temperature has to be there, high snowfall and gentle upper slopes for continuous accumulation. When accumulation is greater than ablation, accumulation is greater than ablation. Ablation means where you will see melting, sublimation, all those things. Accumulation, when snowfall exceeds melting, there you will see accumulation, no melting. Then if accumulation is more, then you will see the formation of glacier. ELA, equilibrium line altitude, is very important. If this is accumulation zone, this is ablation zone. Now, it is a boundary, ELA is a boundary between accumulation and ablation, means above ELA you will see accumulation, below ELA you will see ablation, means melting, sublimation, all those things you will see. Clear? Boundary between the two. Now, the rising ELA means glacial retreat, lowering ELA means glacial advance. This you can learn in climate change. For example, 3 mountains are there. Here ELA is here, here accumulation, here ablation. Rising, here rising, ELA 1. Rising ELA means accumulation is less, means glacial is retreating. In climate change you can use this point. Now, advance ELA, ELA 2 means accumulation is more than ablation, means glacier is advancing, glacier is advancing. Here few erosional landforms we are going to see in glaciers. First, Kori, or a cirque. It is a bowl shaped like a hollow at the head of the glacier valley, cirque formation. How first snow accumulates in the hollow, snow to fern, fern to glacier. Now this is a snow. After compaction, it forms fern. Next, large ice crystal to, now this large ice crystal movement happens, that is known as glacier. After glacier formation, this glacier, what happens, ice movement you will see, and this glacier it plucks, plucking and abrasion you will see, plucking and abrasion, abrasion, grinding, plucking and plucking means the glacier, that ice body, it plucks the sand or rock particles or load from that mountain. Abrasion, grinding, because of that grinding you will see erosion. Here glacier is there, here you will see plucking and abrasion. After plucking and abrasion, what happens here? A hollow shaped or a bowl shaped landform is formed. That landform is known as cirque. Cirque. Clear? Next, arete, a narrow knife-edged ridge formed between two adjacent cirques. Example, here one cirque is formed, here one cirque is formed. This narrow. Now these are bowl-shaped hollows, right? Now these raised knife-edged ridge between these two cirques is known as arete. Cirque is hollow shaped, it's a depression. Arete is ridge. Arete is ridge. Backward erosion of cirque. When two cirques, they are backwardly eroding. Middle, here you will see knife shaped, knife edged ridge formation. Now when these, a sharp pyramidal peak formed when three or more cirques erode a mountain from different sides. For example, three cirque formations from here, from here, from here. They are eroding backward. At tip, you will see a horn, pointed structure, that is known as horn, headward erosion from multiple cirques. Here cirque, here cirque, here cirque. Clear? Tomorrow we will continue with other landforms and we are going to discuss a few more MCQs regarding your UPSC Prelims 2026. Glacial landforms we are going to finish, and coastal landforms along with wind landforms we are going to finish tomorrow. With this, landforms chapter will be finished tomorrow and we will discuss few MCQs also. Thank you.